Hello, welcome again to Beta Things. I will be Paul Myers. Today, I know we said we were going to talk about the super awesome marble lock, and I'm super excited about it, and I'm working on it, but it's just a really big print, and I know I'm going to need more than one prototype, and so I've been procrastinating. I've been procrastinating on that. But instead, today, we're going to talk about Pokemon and parametric programming. So, this was an old project. Old, like it's a couple months ago I did this. Right when Pokemon Go came out, and people's batteries in their phones were dying, and they couldn't keep playing because they needed an external battery, and then people went and got the external batteries. And what I wanted to do was allow people to show off that they're playing Pokemon Go by actually carrying the clip broke off of this one, but a clip-on sort of built Pokeball with a battery inside of it so that they could keep their phones going. And I even did a video promo for this thing, and I did the touring on Reddit and Etsy, try to get people excited about it, but it was just sort of falling on deaf ears back then, I guess, because of the influx of Pokemon Go products. But just recently, I've sold 2 of them, and lucky me, I couldn't find the battery that I based the original design around. And so I had to go out and find a new battery, which is not far off of what the other one was, but still it wasn't going to fit. And so I'm going to use this as an opportunity to show off what parametric modeling does, because it's beautiful. You can go back into your model after the fact and change 1 or 2 things, and then recompile the entire thing, get your new object with your changes. It's great for prototyping. Let's jump in before I'm just gonna keep singing the praises. So, this is my model. And so before I designed it, I had to think about how the pieces were going to come apart, what the print orientation of those pieces was going to be, to deal with overhangs and whatnot. So you see, this is the basic sort of assembly. Top piece prints bottom down, bottom piece prints top down, so it creates this arc, which isn't too bad of an overhang. And then they're clipped together with 2 friction fit pieces that are then glued together themselves. The clip on the back uses a dovetail that just sort of slides on and that glues in place. And then the front piece here is just strictly decorative, is actually held on by the white piece here that goes straight through it, and they glue onto the frame. And the bottom piece here, it's just a little sliding door, so you can actually swap your battery core out and still keep your super awesome looking Pokemon trainer persona. And so let's look at parametric programming here, or modeling. I call it programming, but I guess the word's modeling. It's like you're programming objects. So I'm just gonna try to, I'm not fully on the screen here. Okay. So here on my left is the tree. It's called the tree. This is all sort of common to the SolidWorks model or the SolidWorks sort of workflow. The people that made Onshape are actually dropouts from SolidWorks that were getting too tired about how bogged down SolidWorks has become. And so they created this, and I love it. It's just the best thing ever. But yeah, so basically it uses industry standard sort of workflows, which is great if you want to be going back and forth between, like, I do go back to SolidWorks a little bit for certain things, like Onshape can't do equation curves and a few other things. But anyways, this is the tree. At the top of the tree, you'll have your main planes, top, front, and right. You'll see that they highlight in the viewer as I go over them in your origin point. And then right in, if this was a fresh document, this would be blank below it, but you'll see it starts with a sketch. Everything starts with a sketch and then has something applied to it, like an extrusion or a sweep. And so this was actually the part that I had to change to make my battery fit. So what I can do here is say roll to here. It's going to roll back through all of the stuff that happened after it and just show me that. And I can enter the sketch here. And these are the measurements for the battery, or two of the measurements for the battery. I've already changed this, so I'm just going to leave that as it is. It's going to roll right back through here. Oh no, it's going to stay there. And so you can see I can roll through one at a time. The extrude here is my third dimension of that battery, so I just put that there. And then it's just all sketch based, which is beautiful. And then you can actually refer to existing geometry. But here I am just sort of getting the rough shape of it. Did a thicken here that is a new, yeah, it's a new thicken, so I didn't add on to that existing shape here. I created a shell around it that I'm going to use in a minute. Let's go through a few of these things. Just, yeah, so a couple of, I did a boolean to add those two shapes together, fillets, and you're just sort of sculpting this shape. I'm trying to keep a few things in mind at the same time, but oh no, don't start dragging things around. Yeah, did a couple splits, got rid of some pieces. And this is before the shell. Let's get below the shell here. Shell is a great command for taking material out that you don't need. You select a face, in this case I think pick this one and this one, and you give it a wall thickness. I think this was like 2 mil or something, and then it shells everything out. It just gives you a hollow area, because I don't need anything in there. I don't need to be filling it. And it's plenty strong with the 2 mil walls all the way around, especially in this shape, so it's a time saving on the printer for sure. And it's a really quick move. You don't have to do a lot here in Onshape, or in a lot of programs that use the shell command. But yeah, so I'm just basically designing this thing around the battery, and Onshape with booleans and offset face booleans allow that to happen really easily. You'll see that the walls here, they don't touch the battery. I've given it a fit allowance of like maybe a mil between the two sides, and to do that it was just a single move saying take this battery out of this shell with a 0.5 millimeter allowance, and there it is. So just scrolling through a bit further, doing a bunch of stuff, adding the black middle part. That comes with the, yeah, these tabs. Oh, this is before the boolean. You'll see this cross section, or the crossing geometry here. I'm going to run a boolean in a second here that's going to take that lip off, and it's going to give it the fit allowance. I think I give it 0.2 millimeters all the way around. Gives a decent fit on this axis of the printer at least. Where's that boolean gonna be? Oh, it's way down here. Let's just jump through. And we've done a few other things, but there it is. So there's that boolean. Gives you the 0.2 mil allowance all the way around, which basically ends up being a tight fit after 3D printing, especially with a machine like mine, which isn't great. Yeah, and these shapes were created very simply. Just creating a circle, extruding it. This is a fillet that was applied to that circle. Did a little indent in here for the white part, and this is obviously again just extruded sketches for that detail there. And then coming down, I'm just going to roll right to the end. You'll see the trap door here on the bottom up here, and that. Oops. And that's just a mixture between extruding planes, doing cuts and booleans for fit allowances. I did this nice little tab at the back, so it only comes off one way. But yeah, probably a bit of a long run through there for you, especially if you're not inclined towards modeling, but it's so cool, I gotta show it off. And so yeah, these are the parts that came off. This is the top part, and it's got the mounting point at the back for the belt clip. And there's the shell, like I showed you. And so this piece at 20 thou allowance just pops right in there, holds itself. I'll glue it for the final assembly, but just to show you. And I've already done this one, and so I'll glue those two together, get them registered, and then you've got the black piece here with a little white button. The white button sticks out the back, goes into the hole in the front here, that'll glue into place, and then you got a Pokeball. And I just love it when something comes off the printer and fits right away, like this joint here. Just slide it right in, and there's your door for the battery. Where's the battery? So yeah, it would be in here with your top on or whatever, but if you want to take it out, just pull off the door, change your battery out, put a new one in, boop, and slide it closed. And oh yeah, this one fits too. Great fit. 0.2, guys. PLA, anywhere above 0.1 mil layer height. 0.2, that's your offset all around. It's great for a nice sliding but tight enough fit. Right off the printer, right? That's super awesome. So yeah, I got 2 of these to send out, and I wanted to do a video to show them off before I did. So that's this video. The marble lock is coming because I've deemed it to be so. It will be a real thing because I want it to exist. And so you'll be seeing that next time. Yeah. In the meantime, I have been Paul Myers. Thank you for watching Beta Things.